Hey, this is Mr. Ayton. This is the newly released 2023 AP Chemistry exam released on May 1st, 2023. This is going to be free response question number 1. All your chemistry needs, all your AP Chemistry needs, if you're a teacher or you're a student, go to MrAyton.com to check it out. And this question was all about manganese, You can see right away they ask for the complete electron configuration for a manganese atom in the ground state. That's 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d5, which means the manganese is going to lose 2 electrons normally. And you can see when manganese forms those cations, those electrons are going to be lost from which subshell, the 4s. That's why oftentimes manganese will be a positive 2 charge because it loses from the 4s before the 3d. Well, then this question turned towards an experiment that a student would do. The student's going to do an experiment where they take manganese solid, add hydrochloric acid. They're going to get some sort of manganese chloride compound, an aqueous compound, and hydrogen gas. And so this is going to help the student determine the empirical formula of the compound. And the manganese is the limiting reagent, it says. The hydrochloric acid is an excess. And they give you a table of data here. A mass of an empty beaker, and the mass of the beaker, and the manganese. So if you subtract those first 2 numbers, that gives you the mass of just the manganese. And remember, the manganese is is limiting. It is going to judge how much manganese chloride you're going to produce. Well, they also have the mass of the beaker, the manganese chloride compound, after heating to constant mass. And so if we want to know the mass of just the chloride, we're going to take the mass of the beaker and the manganese chloride, subtract from the beaker and the manganese, and we end up getting 1.41 grams of chloride. And we take those 1.411 grams of chloride, we divide by its molar mass, and that gives us, for part C, 0.0398 moles of the chloride. Well, we're going to want to try to find the empirical formula. So we're going to take those moles of chloride, but we also need the moles of manganese. And you can see in part D they gave us the moles of manganese, 0.0199 moles of manganese. You could have found the moles of manganese by taking the mass of the beaker and the manganese, subtract from the beaker, divide by the molar mass of manganese, and guess what? You would have gotten the exact same amount, 0.0199 moles of manganese. And of course, to find an empirical formula, any formula is a ratio of moles. So you're trying to find out what's the ratio of moles from manganese to chloride. If you don't see it, divide by the smallest one, and that gives us a 1:2 ratio, which means the empirical formula is MnCl2 for this manganese chloride, which means manganese does have a positive 2 charge within this compound. Well, there's one last part of this lab type question, which is a laboratory error question. The student notices some of the manganese chloride splattered out of the beaker. And it asks, will the number of moles of chloride calculated in this trial be greater than, less than, or equal to what we calculated in part C? And it's going to be less than. And we just use logic in order to explain that. If the MnCl splatters out, there's going to be less measured mass of the beaker and the MnCl after it's dried, obviously. There's some of it's splattered out. So if there's less mass of this beaker and solid, there's going to be less calculated mass of just the chloride. Therefore, there's going to be less calculated moles of the chloride. It's just a logical conclusion to what happened in this experiment. Well, part F goes to a totally different way with manganese, and it switches to an electrochemistry problem. And you can see how they gave us 3 half reactions in this little table. And in part I, they want us to figure out part 1 of F. They want us to figure out the balanced net ionic reaction for the greatest thermodynamic favorability, which means we want the highest, most positive E value overall, which means we have to flip the most negative. We got to flip one reaction. The one we flipped is the oxidation reaction, the one at the anode. So you can see that second reaction, we're going to flip that. And you can see I flipped it. Zinc solid plus 2 hydroxide ions makes zinc oxide plus water plus 2 electrons, and that gives us an E of positive 1.28 volts. Well, if we want the most positive overall E, I'm going to add that to the positive 0.15 volts, which is the third reaction. The manganese dioxide plus the water plus 2 electrons. This is the reduction reaction, the reaction that occurs at the cathode, and that makes the Mn2O3 and the 2 hydroxide. and just cancel out the things on both sides, and we're left with this reaction, which is zinc solid plus 2 manganese dioxide solid gives you zinc oxide solid plus Mn2O3 solid. And that gives us an overall E of positive 1.43 volts, which obviously is question number 2. What's the voltage? What's the E of the cell? And it's positive 1.43 volts. We've already done that. Part 3 asks for the Gibbs free energy, the delta G, and the equation for delta G is negative NFE. Negative N is the number of electrons that's transferred. You can see in both of these reactions there's 2 electrons released and 2 electrons absorbed. So there's 2 electrons transferred. The F number is Faraday's constant, 96,485. That's in your equation sheet. And the E, of course, was positive 1.43 volts. That gives us negative 275,947. And the SI units of that is joules per mole. So they wanted it in kilojoules per mole. We just divide by 1,000. We round to 3 significant digits. So that's negative 276 kilojoules per mole. Well, the next part of this problem asks, a student claims that the total mass of the alkaline battery decreases because the anode loses mass. Well, let's think about what's happening here. We know that the first reaction is the anode, the second reaction is the cathode. Look at this electrochemical cell. There's no gas being produced. It's all contained in one cell. So you think about it. This is going to be a disagreement with the student's claim. As the battery operates, the total mass of the battery is conserved. There's no gases that's formed. The entire mass of the system is enclosed. Therefore, the total mass will be the same throughout the entire reaction. Okay? And that was the free response question number 1 for the 2023 exam. Check out MrAiden.com, and I'll catch you for number 2. See you. Bye.